Hello, in this video, we are going to look at a TSP strategy. Remember, TSP stands for Traveling Salesman Problem, the story in which a salesman has a home city, travels to other cities, makes some kind of route, at the end comes home, right? So this is a circuit. It's a special kind of circuit called a Hamiltonian circuit, in that the traveling salesman travels to every vertex, but does not worry about traveling down every edge. In this time, we're going to look at a strategy called sorted edges. We've already looked at nearest neighbor algorithm and repeated nearest neighbor algorithm. In this method, number one, we will select the cheapest unused edge in the graph. So that means we're not concerned with where the traveling salesman begins. We're not concerned with a starting place. Now, normally we've been doing routes from the beginning to the end, right? We've kind of been thinking about, okay, where do we start our route and where do we end up? In this strategy, we don't worry about it. We just grab the cheapest edge. And then step two, we're going to repeat step one, keep grabbing the next cheapest unused edge unless one of the two things takes place. Either A, if you add an edge and it creates a circuit that doesn't contain all the vertices, you wouldn't want that. You wouldn't want to make a complete circuit. I'll give you an example in the picture at the right. What if you made a circuit with that triangle right there? Well, that's a circuit, right? It's closed, but you haven't gone to all the vertices yet. That's not good. Or two, adding the vertex would give, adding the edge would give a vertex of degree 3. We don't want a vertex of degree 3. We only want it to be degree 2, right? One line or one edge coming in and one going out. And then the last step will be to really repeat all this process until a circuit containing all the vertices is formed. Sometimes when you get to the last vertex, you have only one choice. Let's take a look at some examples. In this example, we have a complete graph with A, B, C, D as our vertices. Notice that they're all connected, right? And we're not going to worry about a starting or ending place. We're just going to grab the cheapest unused edge. At this point, the cheapest unused edge, if you look at all the weights, is 8. So I'm going to grab that. Now, one thing I like to do is I like to kind of highlight the graph. That way I know where I'm at so far. Okay. Now, I'm not going to write down my circuit yet. That's the goal at the very end, is to write down what this TSP circuit, right, when traveling salesman circuit would be. So I'm just going to keep grabbing edges. Now, the next cheapest one is a 10. And normally the first two edges you can grab safely. Now, when you get to grabbing the third edge, you have to be careful because remember, there's two things we can't do. Number one, we can't close the circuit. So right now I could not, for example, grab, although it's not the next cheapest, but I could not do CB because notice that would make a complete closed circuit. Okay, I'm not allowed to do that. And I'm also not allowed to do vertex degree 3. So let's look for the next cheapest number. The next cheapest unused edge is 12. However, when I do 12, look at that. Look what happened. I created degree 1, 2, 3 at D right there, right? See that? That is disallowed. So there's two things that you can't do. One, you can't create a closed circuit without all the vertices. Two, you can't do degree 3. So that just means for us, we can't use that one. So then I look at the next cheapest edge. After 12, the next cheapest is 18. I can grab that because that doesn't make a closed circuit right now. Notice if I started at A, I would go A, C, D, B. At this point, you can see I've actually have every single vertex traveled to. I just don't have a complete circuit. So then I have no choice. This is kind of sad, but I have no choice but to go ahead and close this circuit by looking at the two ends that don't have degree 2, and that would be A and B. I have to close it up by connecting A and B. Unfortunately, that forces me to grab an edge of weight 38. So my circuit, if I want to pick a starting spot, I could pick A. You can see that if you start at A, you could either go to B or C from there. So I'll just write it as B. And then you go across this line to D, or that edge, and over to C, and then back up to A. That would be my circuit. I also could write that in reverse order, it would be the same. So what I mean by reverse order is if you went the other direction, if you started at A and then went to C and then D and then B and then A, that is the same circuit. Okay, same answer. Now, the problem with this is that this was a strategy, but the goal was to find a weight that was small. But the weight of this particular circuit is 8 plus 10 plus 18 plus 38. And I'm going to go ahead and add that up on my calculator. But the The problem is we don't necessarily know or even think that that's probably the smallest weight. So alas, this is a new method, but it does not always give us the best answer either. Okay, let's take a look at one more example. In this example, the traveling salesman has a home, which is Seattle. So when I write my circuit, I'm going to just think about that being my starting and ending spot of Seattle. But remember, in this method, I don't concern myself with starting from there. I just grab the cheapest edges. Now, the cheapest edge in this picture is 70, so I'm going to grab that. The next cheapest is 75. I'm going to grab that. The next cheapest is 85, which is fine because I can grab that. Notice I haven't closed the circuit yet, and I don't have degree 3. Those are the only two things I'm looking against. The next cheapest edge is 100. Grab that. And then I have really no choice but to close this up. At this point, every single vertex is connected, so I have to just close the loop. And that would be by just connecting Seattle and Dallas. So this time, it actually worked out really well. I did not go through the middle ever. I just traveled around the perimeter. And not only did you'll notice that all of the numbers in the middle are actually larger. So not only did I find a circuit, but I found the very best circuit. This is called an optimal circuit. So sometimes this method, this technique, will give you the very best answer, and sometimes it won't. Now, when I write my circuit, I'm going to write it in order from Seattle. All right. So I'll just put S for Seattle. Now you can go either direction. I'm just going to go clockwise. So next I'm going to go to LA, and then I'm going to go to Chicago, and then I'm going to go to Atlanta, and I'm going to go to Dallas, and finally back to Seattle. Or remember, you could write that in reverse order. It would be the same answer. The weight of this would just be taking all of those edges and adding it up, and it would in fact be the optimal circuit or best weight. Okay, time for you to practice. Now that you've practiced, I hope that you have a better understanding about the technique called sorted edges.